I think we'll get started. I guess now would be a time, if you have a chance, go to this. It'll help me with the demo. I'm going to track some performance metrics on this site to see what people get on their phones on average. So I guess if you get that, take a minute to memorize the address here, and we'll get started. All right, so today we're talking about building lightning-fast websites. So a friend of mine put out a good tweet earlier today. Let's keep the in unconference. You know, the theory behind the unconference is that there's more brain power in the seats than there is at the podium. So, you know, especially, I mean, a bunch of you here collectively, I know that you have some great stuff to share. So if you have questions, comments, anytime during the presentation, just jump in, you know, raise your hand or whatever. You know, I love to be interrupted. It actually makes things easier for me. And I'd like to start off with a little poll. So who here is a developer? All right, how about who is a leader, manager of some sort? Got some of those. Who's an entrepreneur? Some of those as well. All right, and those of you who are developers, who does front-end development? All right, just about everybody. That's good, because we're going to be approaching this from the perspective of the front-end side for the most part. How about back-end? Who does back-end development as well? All right, what back-end, what frameworks do you guys use on the back-end? Just shout it out. Spring? Ruby on Rails? SQL? All right. Anything else? People use .NET, PHP? All right, we better do a show of hands on this one. All right, who does .NET? PHP? Java, Spring, anything like that? And Rails? Awesome. I love this diversity. You know, I'm traditionally have done all .NET stuff, and it's all .NET all the time, and so I like to see, you know, people that have been working in backends other than that. It's you know, a lot to learn from each other. Okay, so introductions. We did some introductions. Oh yeah, here's another question. Who is working on client rendered apps, meaning you're using Angular or Backbone or something like that to render your HTML in the view? Okay, some, not all. That's good to hear. And does anybody have anything specific that they're interested along these lines that they want to talk about today, or they have specific questions? If you know, if you think of anything, just shout it out. I'll try and get to a bunch of stuff, but I want to make sure that, you know, we're all getting some value out of this. As for myself, I'm Joe Strumman. I've lived in Minnesota my whole life, went to high school, college here, been working here since then. About a year ago, I quit my job working with Jen at ILM, and I founded a startup that was focused on making websites load faster. And it was supposed to be a system as a service kind of thing. And didn't have a whole lot of success with that. I was able to make some progress, but I'm back to consulting, and so I'm helping companies with their web performance issues right now. That's what I'm working on these days. Okay, 1 second and 100 milliseconds. These are the numbers that I put in the talk description, which I'm guessing you all read. You know, what made me pick these numbers? I guess, you know, they're round numbers. They're pretty easy to think about. You know, we know how long a second is. We can maybe guess at how long 100 milliseconds is. They're also sort of common pillars in usability. Way back in 1993, Jacob Nielsen, who is kind of a pioneer of computer usability, did these studies about, you know, how long can the computer take to do certain tasks before people lose interest or before they become less productive. And 1/10 of a second and a full second were two of the real cutoffs they found. If your system is reacting in 1/10 of a second or less, it feels instantaneous to the user. They click and they don't perceive any delay. For a 1 second delay, they can tell that the computer is working. You know, they feel that there's a delay, but it is still short enough that they're not going to get distracted. They're not going to Alt-tab over to their email and look, you know, think about another email that they got to reply to. It will keep them focused within the task. When we have websites that are taking 3 to 5 or more seconds to load, that means every page click that the user's doing, it's an opportunity for them to get distracted, for them to, you know, do something else and not engage with whatever your website is. You know, if if you have an e-commerce website, that's a big problem because it means they're less likely to buy from you. Even if you know, your website isn't e-commerce specifically, but it's, you know, some, you know, service that people are using, they're going to be less engaged with it. They're going to like it less if it's taking more than a second to load each page. And the other thing about these numbers is that they're kind of at the limits of what's achievable in the current state of the art. You know, we can make websites that are this fast in the year 2015 based on the internet speeds that people in the US have. You know, this probably wasn't true 5 or even 2 or 3 years ago. You know, broadband usage is pretty much total. Nobody's on dial-up anymore. And the mobile networks that people have for their phones are actually decent now. I mean, the difference between 4G and 3G is massive. Okay, so what 1 second before what exactly? I mean, when has a page loaded? There are a lot of ways we can define this. So from the browser side with events, there's the DOM content loaded event. There's a window on load. Neither of these necessarily relate to has the page, you know, is the page ready for the user? You know, DOM content loaded means that everything in your HTML document has now loaded. Well, you know, you might be doing more work in JavaScript. You might have AJAX calls that are being sent off to load data. Or your page might have, you know, been looking fine already and it's just been doing cleanup work. Window onload means absolutely everything associated with the page is done. There's no more network activity. Well, that's, you know, hopefully we are designing our sites so that they are usable before every single byte has been downloaded from the network. You know, if images in particular, as images are loaded, hopefully our site is usable before every image is displaying entirely on the page. So the two things that I think are really important to keep in mind are, first of all, when is the page rendered on the client? For a traditional server rendered page, the browser will render something as soon as it, you know, as it parses the HTML. So likely that's going to be before it downloads any scripts you have referenced at the end of the body. And then the other thing to keep in mind as a benchmark is when is the page interactive for the client? So, you know, a typical site is going to have all the event hookups and stuff like that in the DOM content loaded. And so clicking links, buttons, any sort of JavaScript interactivity probably isn't going to work at that very first second the page is rendered. It's going to take a little while for those scripts to download, run, etc. So, you know, there are a lot of ways to define this, and it's different for each page. But these are the two metrics that we'll focus on here. So today, to figure out how to make these websites so fast, we're going to talk about, you know, how does a website get loaded by a browser? And we'll go into some pretty deep detail about that. And in particular, we'll talk about what factors of this loading process make it slow. And then we'll talk about ways to fix it. And how can we make it faster and not slow anymore? Before we dig into the what and the how, let's talk a little bit about the why, though. You know, all of us in this room, we're probably technical in some sense. You know, we're pretty confident on the internet. When we want to do something on a web page, you know, we can probably easily figure out how to do it. We know which button to click. We know it's going to work, or it's probably going to work. We're the exception. I mean, most people out there, and I don't just mean grandma either. I mean most people out there that you would think are pretty tech savvy, they're still not comfortable using websites. And when stuff is taking a long time, you know, they get uneasy in various forms. So, you know, here's some stats that people have published about how web performance has helped them with the success of their website. The Obama campaign, they did some work in 2012. They sped up the site by 60%, and the donations went up by 14%. I mean, they didn't change the copy. They didn't put a nicer picture of the president on there. All they did was make it faster. People started giving them more money. The DoubleClick ad network, they got rid of a redirect that was taking 1.5 seconds, and their click-through rates on the ads went way up. I mean, this is a huge win for their business just by making their website faster. Firefox, their download page for downloading the app used to take a long time. They did some work to make it faster, over 2 seconds faster, and suddenly 15% more people were downloading Firefox. I mean, this is the striking one to me. I mean, if you're going to the page to download Firefox, you're almost certainly trying to download Firefox. Why wouldn't you? But, I mean, the answer is if it's taking a long time, people just don't do it. And that's, that was shocking to me. Another one from Yahoo that I think is interesting because it demonstrates it doesn't have to be a big change. They increased their load time by 400 milliseconds, and they saw measurable increases in site abandonment. People, it would take 400 milliseconds longer, and people would still leave. That's crazy. I think part of it is 400 milliseconds in ideal conditions. For somebody, that's maybe the difference, somebody on a bad connection, maybe it's the difference between 6 and 7 seconds. When we're at work or we're at home, we probably have pretty good internet connectivity. And if it's not, then we'll try again later when it is. That's not true for a lot of people in a lot of use cases. There have been a wide range of sites that have reported stats like this. I just cherry-picked a few for the presentation today. So the bottom line is faster sites are more successful. So there are two speed factors that are really going to impact how fast a site loads: latency and bandwidth. So latency is the inherent delay for any request, and it's limited by the speed of light and geography. So for instance, light through fiberglass takes about 30 milliseconds from here to New York and back, or here to San Francisco and back. Ping times for websites out there are usually like 40 milliseconds. So it's kind of amazing. We have network equipment that can get us, communicating with websites almost as fast as the laws of physics will allow. In other words, latency is never going to get any better. So some terms to keep in mind with this are RTT is sort of an abbreviation for round trip time, 1 unit of latency. And then time to first byte is going to be the latency plus however long your server takes to return whatever content you have. Bandwidth, on the other hand, is what everybody advertises all the time, because bandwidth is always getting better. Bandwidth is download speed. How many bytes can I download in how much time? That's sort of limited by the infrastructure. We can increase our bandwidth but just by putting better and better pipes between us and the places that have data. It's also limited by concurrent downloads. If you've got a fixed bandwidth and all of your downloads share it. Another thing that impacts bandwidth is sort of related to latency. When you start downloading a file, it's not immediately at your maximum download speed. It takes some time due to how TCP works to ramp up to your fastest download speed. And it's sort of tough to predict. It's based on the history of the client and the history of your server, and it's beyond my depth and certainly beyond the scope of what we're talking about today. But just know that it exists. I mean, if you have a 1 megabyte thing and your bandwidth is 1 megabyte per second, it's going to take more than 1 second. So your total download time for a resource then is going to be the latency plus your size divided by your bandwidth approximately. So some typical values for these numbers, our home internet or business internet through cable or DSL will probably have, maybe 20 megabits of download and 40 millisecond latency. And that's just to, general stuff within the US. 4G LTE, it's about half the bandwidth, twice the latency, as, a rough rule of thumb. 3G is so slow, I didn't even want to put it on here, so I graded out. A thing to notice about this is that, if you do the math, you'll find that the bandwidth delay is equal to your latency delay for a 100 kilobyte resource. So that means, excuse me, if you have a file that is 100 kilobytes and you're downloading it in good conditions, the delay from your latency is going to be equal to the delay for your bandwidth, meaning making that file smaller is at best going to take off half your time, even if you made it infinitely small. This is becoming more and more true in recent years. Bandwidth is getting faster, latency is not. So one thing that's different today compared to a few years ago is latency, and reducing the number of requests to make your pages fast is much more important and will continue to be more important. Okay, so let's dig into what happens when an HTTP request is made. So you enter a URL or you click a link or something in your browser. This is what happens. If you're on a mobile device, it's got to wake up the radio. Then you might have to do a DNS lookup for whatever site you're on. You'll have to establish a new TCP connection. You'll have to negotiate SSL, TLS, whatever you want to call it, if you're on a secure site. You have to upload your request. The server has to do what it does. Then you can download the response. And then your browser was going to choose some more time dealing with whatever you just downloaded. So the first 4 of these they're sort of fixed costs. They're out of our control as application developers. You know, we can't make people's phones radio wake up before they click the link. We can't, you know, force our DNS entries into their phone. We can't pre-establish a connection. This is stuff that we just can't get around. So let's dig into those and see how much of our, you know, 1 second, 100 millisecond budget these are taking up. So radio wake up. The way this works is after the radio on your phone has been inactive for 10 seconds, it shuts off the radio, disconnects from the cell phone tower. Doing any network activity at that point, you're going to get a delay of 1/4 of a second. This is on 4G, just to send a single byte. Even if it's been only a tiny amount of time, like 100 milliseconds, it goes into a lower power state where you get an extra 50 millisecond delay re-establishing its link with the radio tower. So your phones are sort of continually communicating with the towers to determine, should my radio be asleep, should it be awake, when can I broadcast, etc. Like I said, this is for LTE. 3G is way worse. We don't even want to think about that. So yes, there are definitely people who rely on 3G. What I'll say is that anything we can do to speed up for 4G will help 3G, and we're never going to make 1 second, 100 milliseconds on 3G. Ilya Grigorik he works for Google on their web performance team. He has a great video on YouTube where he goes into this stuff in more detail. I've got the link in the slides. You know, it's pretty interesting to watch. Okay, DNS lookup. This is something we don't think about too much. DNS is, you know, what changes a website address into an IP address, so we can start sending bytes. You know, ideally, this is going to be cached, you know, whether on your device or on your ISP, so you're not going to have to do a full lookup. But the reality is more and more browsers have to do DNS lookups more often than they used to. CDNs and platform as a service, basically anything that's promising this is going to make your site more reliable. The main way they do that is with DNS. And if your site goes down, they reroute the DNS to a different server. For that to work, they have short cache times on the DNS records. So 60 seconds, you know, for CloudFront, for instance, if you run your site through Amazon CloudFront, your DNS time to look up is 60%, or 60 seconds. And that means at that time, you know, the client's browser is going to have to refetch it. And you know, combine that with if your website isn't getting a ton of traffic and DNS caches are, you know, your ISP doesn't cache one DNS cache for everybody on Comcast or everybody on CenturyLink. You know, it's bucketed geographically. So it's more and more common to get DNS lookups on the browser. And the time it takes is going to be one latency hop plus an extra, you know, maybe 100 milliseconds, depending on a bunch of factors we can't control. All right, TCP connection is one RTT. That's just to say, hey, joestorman.com, I want to connect to you and download some data. HTTP keep alive is a way to prevent having to open up a new TCP connection on every website that you go to. So I shouldn't say that, on repeated visits to the same website. So if you go to my site and then you click another page within 60 seconds, you're not going to have to open a new TCP connection because it will have been kept alive. The other interesting thing that's happening with TCP connections is Speedy and HTTP2. What they allow you to do is have one connection to one server and make multiple requests through it. So if you've got a website that's going to download 5 JavaScript files from your site, if you're using Speedy or HTTP2, you really only need one connection. Okay, TLS negotiation. This is for doing HTTPS, any secure sites. It adds an extra 2 latency hops to your performance, minimum. Plus, you're going to have some CPU time to do cryptographic operations. And then additionally, the browser might have to do some network checks to validate that the certificate it got is any good. So, this is another source of overhead that we can't really control too much. The good thing is it's valid for the entire connection. So if you keep alive your TCP connection, you don't have to redo TLS. And the other good thing about TLS is it has this session resume feature where once you've established one secure connection, you can reestablish a secure connection after hours, and you get to skip one of the hops by using caching either on the server or the client of, here's the cryptographic stuff for the certificate. So then, oh yeah.
For browsers that actually do bother to check OCSP, if your app is running on a recent Nginx or on Apache 2.4, there's a feature called OCSP stapling that will cut down on 1 RTT to the certificate for a server.
Yeah, that's a great point. So I'll repeat it so the video gets it. If your server is set up to do OCSP stapling, then it allows the client to not have to go check the network to see if the cert is valid. That's, I'll say TLS tuning is a pretty vast topic. There's a lot of work that you can do on your server to make sure things are running the way it should. It's not necessarily going to work right out of the box just by, setting up a new Apache instance. Okay, then the other 4 items we saw up there, they're what we as application developers can control. We're going to have one round trip for sure for the browser to actually request the page. And we can maybe expect the browser to take another 1/10 of a second or so to parse and render everything. But this is where we can actually make a difference. So, oh wow, that got small. So you can't see the text on the left, but these rows are the things that we talked about. So radio wake up, DNS, TCP, TLS, you had them all up. For a new, for the very first time somebody visits your page on a mobile site, it's probably 850 milliseconds of time out the window that you can't do anything about. 400 maybe on a desktop. For a repeat visit where it's not going to have to look up DNS, reestablish TCP and TLS, we've got a lot more time. We're down to 180 milliseconds. That's already taken up out of our control. So that number on the right is really bad. We've already blown our 100 millisecond budget. But don't worry, we have tricks to get around that. So you can see we're starting out in a tough spot. We got to make things really fast if we want to achieve those numbers that we were talking about. And worst of all, our websites aren't just one request. The one request is going to get the HTML. The HTML is going to reference a bunch of scripts, a bunch of style sheets, images, fonts, etc. So suppose our page is laid out. Can we read this? Yeah. So it's an HTML document, pretty standard. A few style sheets in the head, one JavaScript in the head, a bunch more JavaScript down near the body. Let's talk about how this is actually loaded and rendered. So we start off, we're going to request the HTML and wait. Then we get it back. And then the browser can parse it, see, this thing needs a bunch of JavaScript and a bunch of CSS. It'll request those files. Now it waits. It's got to wait for those files that are in the head. Once the files declared in the head come back, then the browser can keep going along with what it does. It will run the JavaScript from the head, whatever that does. And it'll parse the body of the page, and at this point, it'll render the page. So it may not have even downloaded the scripts from the end yet, and it certainly hasn't run them, but we can already get a page render. Then once we receive the JavaScript from the body, and then we run it, and then we get our DOM content loaded, and we probably have a bunch more JavaScript to run. So when we're all done, the page is fully ready. It's interactive. We've run all our stuff. So a few rules that this process follows. The browser, all modern browsers are parsing the DOM as they get the bytes over the wire. But if they hit a JavaScript block, then they wait for that JavaScript to run before they will do any more parsing. Because the JavaScript might be doing document.write, injecting stuff into the HTML. JavaScript has to wait for any CSS that precedes it, because it might be accessing the CSS object model. And the rendering, of course, has to wait for the CSS, or it would be displaying a bunch of unstyled content. So a good way to visualize this is something called a waterfall diagram. It's visualizing our HTTP requests. So the x-axis is time. You can see the label over there is 1 second. And the y-axis is the resources that are being downloaded. So in this example, this is for jsfiddle.net. The very first request is the HTML page itself. And then from there, it's going to download a bunch of JavaScript and CSS files. And I cut off the bottom because this one goes kind of long. But by looking at this and knowing how your page works, you can figure out when is my page rendering, when is it fully interactive. You can tell what is going on. This particular version is generated by Fiddler. It's an awesome tool for Windows. If you run Windows and you're doing web development, you need to know Fiddler. But you can also get similar diagrams from your browser debug tools. Webpagetest.org is a great site that will do this for you. Tools, Pingdom is another one. The thing I don't like as much about those is they'll include the DNS and the TCP and the TLS negotiation. And by the time we're dealing with application level stuff, I tend not to care about that stuff, and it's sort of clutters the view, I think. So I prefer Fiddler, but they're all helpful. One other thing to note on here is that black bar on each request is the time to first byte. So you can see a lot of the requests, the black bar is way on the right. And what that means is the file was so tiny that it downloaded basically instantaneously. So it's helpful to know where your first byte is. If you have, for instance, 5 different CSS files that all download instantly, you may want to consider combining them. Okay, so I think we've done a pretty thorough job of digging into how websites are loaded, what the slow points are. So now let's talk a little bit about how we can make it faster. Okay, the number one thing is to make sure your server is fast in returning that initial HTML. Every single thing on the front end is blocked by that initial HTML. Google has a target of 100 milliseconds for anything that hits their server. Unless we're computing the 1 millionth prime number, we can make it reasonably fast. I'd say certainly in the millisecond range. If you have expensive things that are integral to your web or that are part of your website, you can move that out and do an AJAX call. So you can return the initial HTML without that expensive content, and then your page can issue an AJAX call to render it asynchronously. That'll not improve the actual performance of your site, but it will make the perceived performance much better because the users will be seeing something rather than a blank white page as it loads. Another thing you can do is on the server side, the way most server frameworks work by default is they'll render the entire HTML document in memory and then send that entire thing down to the client. But if you have something expensive on your page, it's almost certainly going to be in the body. So what you can do is you can flush the response as soon as you're done with the head on the server. And if your style sheets and your script references are in your head, then the browser has a chance to start downloading those while your server is still chewing on the expensive stuff. So if you're putting JavaScript in the head, you want to add the defer attribute, which tells the browser, okay, I'm declaring this script now, but don't run it until after the body. The other thing you can do, and this is sort of the the Cadillac option, is to make your HTML server cacheable. So Google.com, Amazon.com, both of those, the initial HTML document is public cacheable. It's hosted on a CDN. So the initial HTML document is loaded as fast as possible. There's no real server processing involved. This means that anything personalized has to go and do an AJAX call. and it means anything dynamic has to go in an AJAX call. But this is why, you know, if you pull up google.com, you see the search box right away, and then you'll see your email and stuff kind of filter in the background as it goes. Okay, another great thing you can do is you can eliminate dependencies for your first render. So if you have CSS files that are declared externally in your head, the browser is going to have to download them, parse them before it will display a single pixel on the screen. So what you can do is you can inline your critical CSS, inline the CSS that matters for the very beginning of the page, and then load the rest asynchronously. And then move your script tags to the end of the body, or as I said, use the defer tag. TheGuardian.com is a great example of this. This picture there is what The Guardian looks like after loading only the HTML. That takes 200 milliseconds of just, you know, it returns this. The CSS is inlined into the head. There are a few images inlined as well. You can inline binary stuff like images with base64 decoding or encoding. So it's strikingly fast to visit theguardian.com. I think it's worth a demo here. Okay, so I'm in an incognito window, so you know there's no caching going on. Oof, this gets difficult. Where is my mouse? Here it is. I mean, it's really fast compared to most sites when to initially display something. And you know, they really did a good job using this technique of eliminating all their dependencies. Yeah.
You may have mentioned this, and I apologize if you did, but could you touch on why not to use document.write?
So document.write is fine if your script, if you put your script where it's meant to be. I'm saying that badly. Okay, if you have, sure, yeah. Yep, if you're doing document.write from a script at the end of your body, that's okay. But if you have put the defer tag on your script, then document.write isn't going to work correctly, because defer or the async attribute as well, they tell the browser, you know, execute this later, and it's going to do the document.write later in the DOM, and it's not going to be where you think it is. Yeah.
And also just like inlining things and whatnot, are there tools that maybe they use to like keep this clean in the software to inline everything?
That's a great question. The question is, are there tools? Yes, there's a tool. Adi Osmani is another Google guy. There's a package on GitHub called Critical, and it's a grunt script or a node script that will scrape your, you know, it'll load your page in Phantom.js or something, figure out what CSS is impacting above the fold, so to speak, and extract that into a new file for you. I haven't used it personally, but I've heard that it works. And the other thing you can, I mean, the alternative is just manage it yourself to know, you know, some of my CSS has to go in this critical file and some of it doesn't. But if you're interested in this, I'd recommend checking out Critical is the name of the project on GitHub. Yeah, I'd love to hear some feedback about if it works or doesn't work for somebody. All right, we'll move on to a quick one. Gzip Compression. It reduces your text file size by like 70%. I mean, use it. Even for dynamic content, it's worth it to use it. Don't use it for images, that's pointless. But please, if you don't do anything else after coming to this today, like go back and make sure you have Gzip Compression turned on your servers. You know, it's potentially a big benefit for about 5 minutes of work. There's a major sandwich ordering website that downloads downloads a full megabyte of JavaScript, and it is not Gzip compressed, and it just kills me inside. Caching strategy is another thing to think about. So there are 3 headers in your response that will affect the caching strategy or affect how your files are cached. So there's cache control, which is basically, you know, you can say public or private, to indicate whether it's cacheable for everybody would be public or just the end user would be private. You can specify a max age to cache it for, or you can say don't cache this thing at all, it's sensitive information, it shouldn't be persisted to disk. The other headers you can set are etag or last modified. These basically give each file a version so the browser can later on check, has it changed since this version? And the server can just say no. Yeah. No. So the best way to do it is to put that version into your URL for your script or your style sheet or whatever your static file is. So for instance, if you link to your site with a version that's a file hash of that version, you can give it a huge max age for your cache control public, and then it'll be cached forever. Nobody will ever try and look it up again. No, if you use etag and last modified, it's certainly better than nothing. But the downside is there will be all these requests that have to go, and they're going to incur latency, like we talked about. They don't download any content, but it's still a hop to the server, and the server's just going to say, nope, it hasn't changed, and that's going to harm your performance. So that's a good point, good question. Something to keep in mind with caching is just because your website has the caching set up right doesn't mean it's fast. I mean, caching will help return visitors, it'll help navigation in your site, but it isn't going to help your new visitors. And it's not going to help if you're updating your cached files all the time. So this, for instance, this is a website that is doing sort of the versioned resource thing that I talked about. In their JavaScript, they're putting a timestamp, probably the deployment date, on their JavaScript files. But this image is about a week or so old. I took this screenshot. You can see it's March 20th, 2015. I took the screenshot on March 22nd. And then I went back to the site 2 days later, and that timestamp had changed again. So the cacheability for these files isn't really helping because they're changing it on the server all the time. Nobody's going to have it cached. In cache miss rates, I think, I haven't seen a lot of studies on this, but I think they tend to be more misses than we would expect. So Yahoo did a study on this in like 2007 when Yahoo was by far and away the #1 site on the web. They put a tiny little image on their page, and then they were able to measure for each visitor, was it cached or was it not? And what they found for yahoo.com, the most popular page in the world in 2007, half the users did not have that file cached, and 20% of the page views. So, my soapbox is if you think caching is good enough, it's not going to help you as much as you probably think. Okay, another thing you can do that is not all that difficult is to optimize your file delivery. So Nginx, who here uses Nginx? All right, Nginx is a great thing to use to host your static files, or you can set it up as a reverse proxy in front of your application server. It's very fast at serving files, and much faster than Apache or IIS, and it isn't going to load your server with file loads. Both Apache and IIS will take longer to serve files when they're under load, and serving a bunch of files will cause everything else to slow down. Nginx is a great way to, all it does is serve files for the most part. Does a great job. Another thing you can do is a content delivery network, and these are basically file servers that are distributed around the world, or distributed around wherever. And all they do is serve files, so they're really, really good at it. Much better than an out-of-the-box instance of Apache or IIS. CDNs support same domain now. Some of them do, and I think it's a newish thing for some of them. But it used to be that if you wanted something on a CDN, you'd have to give it a different domain name, and that drove people away because it got to be more complex. But I know Akamai and CloudFront and Cloudflare, you can have your real traffic go through your CDN, and then it just acts as a reverse proxy to your origin server for the dynamic content, and it doesn't really slow things down. There are a couple downsides to CDNs. So one of them, like I said earlier, is that your DNS will your DNS time to live will get small because DNS is, that's how they're going to set it, and it's under their control. On the other issue is you might have problems if you want to purge your content. They all pretty much support this in some sense, but they're all, I think, pretty limited in what they support. I mean, they've taken a file that you're hosting and pushed it out to 20 different servers on their side. It's not simple for a CDN to delete that file from all the servers at the same time. All right, Speedy or HTTP2? Is anybody using this? No? Okay. So I'm not either. So I'll tell you about the theory of this. So the theory is they do multiplexing on a server connection, which means when your page is downloading, the browser can download the scripts and the style sheets from the same domain on that same connection. And this is going to speed things up for quite a bit if all your files are on the same domain. There are a few caveats. HTTP2 is brand new. It was just ratified about a month ago. It's replacing Speedy. Speedy was sort of like a precursor that was, a prototype, just, let's see if this thing works. It's not supported on old IE or old Windows. And you need to have an SSL site if you want to be able to use it. So, yeah, go ahead. No, it not supported means your site will downgrade to regular HTTP. Yeah. No, it doesn't like break your site. So like I said, in theory, this can be a big performance benefit. But the thing that's weird to me, Speedy has been out for a few years, and I haven't come across a single published thing that says, we turned Speedy on and our site got X% faster. There's a lot of studies about like simulated page loads and how Speedy speeds up simulated page loads, but I haven't seen any real like organic evidence in the wild. So I'd love to see something like that. If anybody ever uses it, I'd love to hear about your experiences. Or if you see something like that, I'd love to hear about it. All right, bundle resources. So assuming that we're not all running Speedy or HTTP2, every individual file that we have is going to incur a latency cost. So if we bundle them together, take multiple JavaScript files, turn them into one, then we'll save a couple latency hops and make our whole site faster. So this is really easy to set up in Grunt. Anybody use Grunt? All right, it's worth showing. So Grunt is built on top of Node, which is JavaScript that you can use to just run whatever you want. You think of it as Node on the server, but really it's it's JavaScript in a command line is what it is. So the way you use Grunt is you set up a Grunt file, which is a JSON specification of what you want to do. So here I'm saying, okay, I want to use, this is the wrong demo. I'm sorry. I don't have an actual demo for bundle. You'll just have to trust me that this is how you bundle scripts with Grunt. So yeah, reduces the request quantity. You have less latency hops. One thing you want to consider when you're doing this is cacheability. So if you're bundling together 3 scripts and script 1 never changes and script 2 changes once a week and script 3 changes every day, it's probably not a good idea to bundle them together because all of a sudden script 1, which should be cacheable forever, is now not going to be cacheable at all. So kind of a common way to do it is to bundle all your third-party frameworks and stuff together and then have your day-to-day application code that might get changed every week or two bundled together. And that way your bundles don't interfere with the caching. Optimize images. So this is another big one. The first thing is to choose an appropriate image format. So JPEGs, PNGs, GIF files, and bitmaps, they all work in every browser. But they have different use cases. So for JPEG, you want to use that if you have lots of colors, if you have fuzzy lines, any like nature scenes, any people, anything that looks like a photograph should be a JPEG. Pings are more line art. They work really well if you only have a few colors. In fact, if you only have like if you have less than 256 colors, they work really well. They index the colors rather than, specifying every pixel. Yeah, go ahead.
Well, I guess I've mentioned a lot. I've mentioned PNGs and optimizing them a lot, especially for Unity games. And I think like there's a lot of programs like Photoshop, they don't get optimized like they could be, but they aren't.
Yep.
So like on Mac, there's a program called Image Alpha. So I mean, I'm sure it exists elsewhere, but like there are programs for optimizing PNGs and JPEGs to use that indexing, which apparently a lot of big programs don't do that.
Yeah. So I'll repeat it for the camera. That's a great point. If you save an image out of Photoshop, it is not going to be small. So PNGs and JPEGs as well. They can have a lot of extra information, and they can encode things inefficiently, and Photoshop doesn't really care about that, and a lot of graphic design tools don't really care. So Scott, you brought up Image Alpha. A few other options are Image Optum. That's a command line one.
Image Alpha doesn't work with PNGs.
Oh, it doesn't. Okay, so
It's really bad on PNGs.
okay. Yeah. Kraken.io is a pretty cool web-based one. They have like a drag and drop thing. You drag an image in there, takes a couple seconds, and it shrinks it down. And the savings you get from doing this, they can be up to 70%. I mean, depending on how bad the original encoding was, they can be really good. Yeah. Yes. Yeah. See, Image Optum does have a GUI. I put it in there because it's good. But yeah, good point. It's GUI and command line. I don't know. I haven't opened Photoshop in years. It does work. Okay. So, you can use a command line. So, that's kind of scary, I guess. You wouldn't necessarily want to run some, Image Optum on something user generated. So I don't have any experience with that directly, but I know there are a few companies, including Kraken, that have an API where you can upload an image, and then they'll return a URL that you can download the optimized image. So I would think a web-based API might be a good choice in that case, because depending on who your users are, you might not want to be running command line programs on user-generated content. Yeah. Okay, great. I'll repeat that for the camera. The reports are that Image Optum can work better than Photoshop Save to Web. It's probably worth experimenting with whatever your workflow is. It's worth doing something. Another thing I want to note is choosing appropriate size. And to help with this, there's a new HTML5 element called Picture. And the way this works is it's probably better to just kind of read that screenshot there than for me to describe it. But essentially, based on your screen resolution, like a CSS selector, you can specify different images to load. You may want to be careful with this too, because an iPhone, for instance, doesn't have many CSS pixels, but it has a lot of real pixels. So if you download a big image to an iPhone, it still looks better, even though the display scaling kind of messes with what you might expect to happen there. Oh yeah, and here's just an example of the optimized images. Each of these polar bears, one is 50K and one is 18K. I don't even know which one is which, and I bet you couldn't even tell the difference. Okay, avoid multiple domains. So this is kind of maybe different than what people did in the past. So the sort of a traditional thing to do has been to break up your static resources over multiple domains, so that they can be downloaded in parallel. But modern browsers will open a lot of connections per host. So this doesn't actually help anymore. I'm going to skip by the demo for this because we're short on time, but I'm just going to, say if you're doing domain sharding right now where you're putting your images on like 4 different domains, you might want to stop doing that. It's probably not helping. And especially if you're going to move to speedier HTTP2, it's obsolete. I'm going to skip web fonts because we're running out of time. That's a little fringe. Because the JavaScript tricks, this is the cool one. Okay, so PJAX, it's push state plus AJAX. And the idea is when you click a link, rather than loading a new address in the address bar, it does an AJAX load of the link target and then puts its content in a div that you've specified on the page. NPR News does this, and it's pretty cool. Oh, first, let's check this out. So this was if anybody went to the demo site before the presentation started, then, okay, there was one page in there that was the Angular ToDo App, and there was one page that was just an HTML file rendered by the server. And so Angular ToDo App got an average load time of 700 milliseconds compared to 350 for the server rendered pages. So I wasn't sure what to expect for the Angular rendered. It's twice as much, but it's still not like multiple seconds. You're not seeing this, sorry. There you go. So this is showing in New Relic the page load times for one page that was rendered with an Angular app and one page that was rendered by the server. So I guess just to take away from that is that if you're going to use something like Angular to do a single page app, you can do it and still have a fast site, but you probably want to be careful. All right, so here is the NPR News PJAX demo. So if I click a story, you can see the page doesn't go white. It's not like a totally new navigation. It just loads something new in this content area. And it seems much faster, and that's because the browser has to do a lot less work. It doesn't have to parse an entirely new document. It only has to parse out a little bit of it. So that library is it's on GitHub, jQuery PJAX. It's worth checking out. There's a trade-off. You lose DOM content loaded, so that means you have to make some changes to your JavaScript. But it can make things appear a lot faster. The other one, which I think is even cooler, is Instant Click. This I have on my personal site, and the idea is that it's doing just what PJAX does, only it starts the fetch on mouse over. So if I go to my website, and I'm going to pull up Fiddler so that you can see the requests that are being made. So as I mouse over this About Me, oh my, what is going on here? Okay, well, just trust me, as I mouse over About, it loaded the About page in the background. So now when I click it, it just shoves it in the DOM. So this has the same limitation as PJAX that you don't have DOM content loaded anymore. You have to reorganize your JavaScript. But it's pretty cool. Let's get back to the presentation. All right, Minify, we'll skip that because we're out of time and you hopefully know about minification. If not, let's talk afterwards. So recap, we talked about how websites are loaded, how we can make it faster. And if you're interested in more reading, there's a couple good resources. The bottom is me. I love to talk about this stuff. I love to help people and companies with this stuff. Steve Souders is kind of a pioneer in this area. He's got a lot of great content on his site. The Perf Planet calendar has, for every year, every day in December, they do an article about some random web performance thing. It's pretty interesting. And then people are always posting stuff on Twitter with this hashtag #PerfMatters. I mean, performance matters for your site. All right, well, thanks for coming and sticking with me, even though I went a little over time, but. If anybody has any more questions, I'd love to talk. If you want to stick around, you can. Yeah.
For InstaClick, my first thought is, wow, that's amazing, but then it scares the crap out of me. in like a scalable application,
Right.
at my job, we run into instances where there's just too much going on.
Right. Instant Click works great if your HTML is cacheable, for instance, and it'd be loaded from a CDN. It also lets you specify a delay. So suppose they have on that instantclick.io page, there's like a test where you can see how fast you go from mouse over to click. I'm like 400 milliseconds. You can set a delay to like 200 or something, and you'll still see, some benefit there. Yes. So I will post my slides online on that demo page, the joestroman.com minibar. Or if you follow me on Twitter, I'll post it there.